I'm hearing an echo.
I'm hearing an echo.
Check the audio now.
In the YouTube, the audio is working.
Yes.
Uh, okay, now I think we can get it. Okay. Okay, so it's great to have all of you here today. I think are all the recipients here already, Simran? Or is someone else going to join us?
Most of them are here. Let me check who is not here right now.
Okay, okay, fine. That's fine. Okay. So, welcome to the Bose Olympiad 2021 prize distribution ceremony. We had a nice run of problems last year, and this year, I think more schools are participating in the Olympiad. We try this year. We are trying to do something different. We are trying to bring in more of research and as a round of the as a round of the Olympiad. One of the reasons I want to tell this to all of you who are attending this one and listening to me. Basically, tomorrow there is another seminar where we will be discussing. Like most probably it's tomorrow. We will be discussing with two of our students, Aryan Kalia and Anushka Agarwal. Aryan is going to Harvard this year, and Anushka is going to MIT. And both of them did have a very interesting journey with us for several years, and that included research projects as well. And so I do encourage all of you to do some sort of a research project if that's possible, and we can definitely help you with that. In fact, this year's in the Post Olympiad 2022, we have a round called the research round, and then there is another aspect that is also very helpful, and all of you will be invited to that, and that's the student internship process. So Aryan particularly did this uh, last year, and with the Chinta North America work group, and Anushka did it with the Center for Education for Girl Children at Chinta. So if you can create something on your own, like an entrepreneurial venture, a little project, work with some people, and you make something good happen. If that can be done, then that adds a lot of value to your academic career in the long run. So, uh, as a part of the prize distribution, now all of you have done really well in the post Olympiad. So, as 2021, so as a part of that, right, part of the prizes, and this was not declared earlier, but as a part of the prizes, I would like to extend um, to all of you research projects and internships for the upcoming year. So that could be part of the prize or awards. Okay. Now, um, Aryan, could you? I also have an Aryan here in this class as well. That's don't be confused with the other one that I'm speaking about. So, Aryan, could you tell me a little bit? Did you want to? Did you remember any of the problems that you encountered in the?
Yeah, yes, I had gone to the forum recently some days ago and the results were out, the score.
Okay.
And I think particularly I found one problem very nice even after the exam There were two, but one stood out. That was, I think, problem four.
Okay.
Um,
So Aryan was a silver awardee in the was Olympiad 2021 senior level, I think.
four. Yes.
Uh, right. Okay.
Um,
So it's weird. I cannot see anyone in the
so
YouTube.
Aryan was
What is going on there? Um, Simran, why can't anyone be seen in your YouTube?
I think now they are visible. I think due I think due to
Okay,
lack
Aryan,
of like I think Wi-Fi network is quite weak, and I think now they are visible.
visible?
Yeah.
Oh, fine. So Aryan, yeah, you were telling me something about the
Wi-Fi network is quite weak.
fourth problem for the senior Olympiad. Go ahead.
yes, I think it was a combi problem, and it had a really nice solution. I mean, there was something within contradiction, and I really liked that one. I think the whole paper was really nice. I mean, none of the questions were something like you can see and solve them. You had to spend some time on them. You had to work something out. It was nothing direct, and I really liked the paper. I mean, it had a mixture of all topics, and yeah, it was fun.
That's great. So, in the problem that you were talking about, the fourth problem from the, let me see that this was pretty. Um, so this was in the senior level, right?
Yes, sir.
So in the senior level, I see there is the 2021 paper is here. This is problem number four. Maybe I can just share the screen with all of you, and all of you can probably see it. Second. One second. I will just go to reference. Access. Okay, so let me try one more time. Uh, okay, maybe it's not going to work in this way. But anyway, the problem was like this: that there were 27 cubes. Are you talking about that problem? That
Yes.
Ananda has 27 cubes, each of edge 1 centimeter, and 9 of them are red, 18 of them are blue. That's the problem, right? So
Yes.
maybe I can just put it here in the chat. Yeah. So uh, do you remember how you solved it? This one.
Yes, sir. So, I mean, if you've seen a Rubik's Cube, then this problem actually becomes easier because you can actually visualize how a cube looks. So,
Okay.
the problem starts by an observation that if you're looking at the cube, each surface, out of the six surfaces on the cube, each surface has nine squares.
Correct.
In all, there are 54 surfaces. And I assume that it is possible that the cubes can be put in such a way. If it was, then I would get no contradiction, and if it was not, I would get a contradiction.
Okay.
So I started by assuming for the sake of contradiction because I was hoping, I was maybe guessing the answer to be no. I was just trying out. So if the cube has the same number of red squares and blue squares, then the number of red squares and blue squares both are equal to 54 divided by 2, which is 27.
Right.
But the problem here is if there are 27 red surfaces and there are only 9 red cubes, and if you know how a Rubik's Cube looks and you have done cube problems before, then you know that the maximum number of surfaces that a cube can have in such a configuration is 3 when it's on the corner. Then it exposes 3 surfaces.
Right.
But and so there are 27 red surfaces and there are 9 cubes, and there are at max 3 surfaces each cube can expose. and 9 into 3 is also 27.
Uh-huh.
So this forces each cube to expose three surfaces, meaning all 9 red cubes have to be on the corner. But that is impossible because a cube only has 8 corners, and that is the desired contradiction. So it actually had a, I wouldn't say it was a coincidence, but the way the numbers matched, and I found that particularly beautiful.
Good. That's great. This is the problem list. If all of you are guessing, this was the set of problems, and Aryan was discussing this problem number four. Now, if you are looking at the website, it now contains all the other problems. So, if you are participating in the Bose Olympiad this year, you would have in the 2022, you will have the material, all the material here right now. So you can access them, in particularly past papers set here. So you can click on one of the links. And this year we also have a couple of other divisions. We have the data science Olympiad for the juniors and the statistics Olympiad for the statistics, upcoming statisticians. Hopefully that helps because right now we have expanded into some other departments and they also want to have some interesting problems that we can discuss. And several schools are coming in this year joining us for that. So, Pranjal, let me hear from you. So, how
Yes.
did your uh,
But I found it rather interesting. So
so,
at first, it kind of seems as like there's no like pure solution. You just have to like do a trial and error. But
okay.
then, like what I thought of is that uh, for any
So,
one,
just before you begin, let me just say a small clap for Aryan for silver in senior Olympiad, and Pranjal has a silver in the intermediate one. So uh, that's a clap for him as well. Okay. So now go ahead, Pranjal. Yeah.
what I thought of was that when we draw a diagonal, we are
So which problem are
draw,
you discussing? Sorry, can you say that one more time? Which problem are you talking about?
I found problem three very interesting.
Problem three of 2021 paper. That's the intermediate one. Okay, fine.
Uh,
So is this
the
the picture one?
Yeah, the one where we have to solve the 5 by 5 square.
Oh, okay. So let me share that. It is a very interesting problem, and we actually got this one from an old Russian Olympiad. This problem was, uh, and it is also it also appeared in a Romanian Olympiad few years, several decades ago. So it's kind of nice. Yeah, go ahead.
What I thought of is that whenever we draw a diagonal, they're
Uh-huh.
going to be blocking two vertices. And so I was thinking like we have to minimize the number of vertices blocked by making as many diagonals as possible from each vertex.
Right.
So then that way the diagram formed in the end is kind of like a grid where the diagonals are all intersecting at 90 degrees. So it's like a complete grid. And that way I think my answer was that there are 18 key vertices.
Yeah. In some sense, there is an algorithm behind this problem actually that you sort of start um, going to the most efficient solution, and there is a method of design and the algorithm, the 3D algorithm. So maybe if any of you do computer science, you know that. Uh,
I've
anyway, so that
over some solutions. I've just learned about the algorithm.
okay, that's cool. All right, very nice. Uh, so let's move on to Aradhya Goel. I think that's the name of
Yes.
it's your mother's name, right? What's your name?
No, sir, sir. I am Aradhya, sir. It's actually Aradhya. Yes, sir.
Arad. Okay, okay. Sorry. Go ahead. So, yeah, tell me which problem you were looking at.
Yes, yes, sir. So I really like, first of all, I would like to start by saying that I really liked all the questions in the question paper. And there was this question number two, which I particularly liked because it was sort of a logical problem which we could solve like through basic logic. And in that, it was that I found that the number of, as it is a circular path, so it will eventually, while counting the number of trees, first of all, the number of trees would be the same between Ananya's first tree and Satyak's first tree. And also, the trick in this was that Ananya's counting would finish just behind her first tree, and similarly, Satyak's counting would finish just behind his first tree. And we had, so in a way, we got two equations, and using that, we had to reach the answer. So, one basic trick was that Satyak's first tree was the 14 for Ananya, and using that, we found that there were 12 trees between Satyak's first tree and Ananya's first tree. And using that, we can easily find the answer, which was 100, I think. Yes.
Okay. This was the second problem from the senior round, which is nice. Okay. So I've got is a bronze awardee from the senior round from 2021. That's great. So that's great. Thank you for joining. Is Arnav Nigam with us today? Maybe not. He's not here.
Arnav Nigam is having some exam. I think he will
Oh,
join
okay.
late, or
He is going
or
to
he
tell us.
might not
Okay,
join.
let's go to Soham Pednekar. Soham is a gold awardee in the intermediate round. Soham,
Yes,
welcome today. So clap for him. Excellent work.
thank you, Andy.
So I want to repeat this to all of you. You are such an encouragement for all other kids. Of course, not only for your performance in the post Olympiad, but other things that you are doing. And I strongly believe that if you have the right mix of um, mathematical Olympiads, research projects, and student internships and all those things, then you can go to the most premier places in the world. In fact, if you are joining late, then I'll also tell you that I want to invite you to the special seminar, which is probably going to happen tomorrow with Aryan and Anushka. Now, most people will listen to it from YouTube, but I will invite you, the people who have who have done really well in the 2021 Post Olympiad, to join the Google Meet of that session so that you can have some direct interaction and mentoring from Aryan, Kalia, and Anushka Agarwal. Because that's what students and other people should do. They should have this peer process. Like some of you are also working with math circles in Chinta, right? Any of you are working here in math circles? Like, are you leading a math circle in Chinta in this group? Maybe not. Okay, some other kids are doing that, so that's a very interesting project to be part of as well. Okay, so could you tell us about the problem that could be useful for I can talk about?
Yeah. So first of all, I would like to start by saying, and as rightly mentioned by the others, that these problems were non-routine problems. In the sense that they didn't have a direct solution, but they rather required logical reasoning and creativity. And as I think Pranjal mentioned, the problem which triggered my curiosity was particularly problem number three. It's the same problem regarding three vertices.
Okay,
Yeah, and my approach was also slightly similar to Pranjal's approach. Basically, to maximize the number of three vertices, we need to maximize the number of diagonals on one vertex. I started by observing some patterns in like 2 by 2, 3 by 3, 4 by 4, and then went to 5 by 5, which was what the problem asked. And I got this answer of 18. And I noticed that from that position, if I modify it slightly, it would always be lesser than or equal to 18. So that is how I arrived at this.
okay, okay, I see. So again, an optimization kind of approach. All right, that's great. Thank you, Shom, for joining today, and of course letting us know. Okay, so your approach. Anshuman Mishra is here.
Yes, sir.
Okay. Hello, Anshuman. Welcome. Thank you for joining. Anshuman is a bronze awardee in the intermediate level. So, Anshuman, could you tell us a little bit about the problems that you're doing? I cannot see you though. Where are you?
Sir, my webcam is not on.
Okay, fine. Could you tell us about a problem that you tried and you liked, maybe?
Sir, does it have to be from the Bose Olympiad?
Yeah, of course.
Sir, I tried doing problem 3. I like first I took like 3 times 3 grades and then 4 times 4 grades and then so on. I found out that we could not actually make the number of such quantity. You couldn't make it more than n plus 1 whole square by 2. So then I used some sort of induction to prove it. The answer was 18. 6 square over 2 or something.
Okay, okay, that's great. So, again, thanks for joining Anshuman. A clap for him. He is the bronze awardee for the intermediate level. Thank you for joining today. And then, Vijay, are you able to hear me? Hello.
Yes, sir.
Okay, which class are you in right now?
Fifth standard, sir. This year will be sixth.
Oh, okay. Fifth to sixth. Okay, he's junior to many of us. That's great. So Vijay, could you tell me about your? So he's a gold awardee. First, a clap for him. It's excellent. Thank you for joining, Vijay. You did really well. Okay, so let's look at the problems set from the junior round. So here we go. Uh, any of the problems that you like, Vijay, that you can tell
No,
us?
sir. I don't remember.
You don't remember the problems. It was far, long time ago. So
Yes.
that's all right. That's all right. So those of you who are joining right now, you can go to the Post Olympiad page and you can check out the resources that are available right now because the registration for this year's Post Olympiad have also started. Of course, you can see the award is here in the first slider, but you can also see the different rounds that will be here. So the boot camp is starting on 6th of April, and then the research project round will start, and then the individual round, team round, and so on and so on. I cannot stress this more that for kids who are right here, right now, for them and for the others, the next century is about asking interesting questions and pursuing them in a systematic manner. Don't have to do it with Chinta, but even if you do it with on your own, try to find some nice questions that you can ask and you can pursue. Because as machine learning and artificial intelligence and all those things come in, the fourth industrial revolution, creativity would be the mainstay of kids like you and for all of us. Okay. So anyway, that's great. And we have Swetanshu Sahoo. Swetanshu, are you with us?
Yes, sir.
Okay, you are in which class, Swetanshu?
Sir, I'm in class 5th. I'm going to class 6th.
Okay, that's great. It's great to have you. You remember any of the problems or not?
Sir, the most difficult question that I found was problem number 3. The same 5 into 5 grid.
Okay, okay. Did you solve it in the session?
No, sir.
Okay,
I tried it, but I could not solve it. When I showed the question to my father, he solved it and said it's 16 to 18, something like that.
okay, okay. All right. We should try and solve the problems as much as we can on our own. That's great.
Yes, sir, I tried, but I could not.
Okay. We have Kanak Rade with us. Kanak, hello. Can you hear me?
Yes, sir.
Okay. Kanak is a bronze awardee in the junior level of the Post Olympiad 2021. So a clap for Kanak. Very nice. Thank you for joining, Kanak. So, you are in which class?
Sir, I'm in grade 5 and I'll be moving to grade 6.
Okay, okay, that's awesome. So, do you remember any of the problems that?
Yes, sir, and I'd like to talk about the question number 4 because it needed a logical approach.
Okay, let me share the screen. That's great. I really like that you are taken the time to look at the problems. Okay, so this is the problem, I think. Ram guessed a three-digit number in which no digit is zero, and all the numbers are different. Rahim wrote down a number in which all digits are the same digits are in reverse order. John subtracted the smaller of the two numbers from the larger one. So what is the last tens digit in the tens place of the number that John found? It looks like a puzzle, yeah.
Yes, sir. So first, I took out all the information that is given to us,
Okay.
like Ramchester did.
Your audio got muted actually.
Yes, sir. Okay. So, sir, 1 second. I think I'm getting. Okay, sir. So first I wrote down. Sir, 1 second. I think. Okay, sir.
Yeah, I can hear you now.
Yes, sir. Okay, so 1 second. Yes, sir. So first I wrote all the information provided with us.
Someone is
Uh,
no, okay.
So there's a second Aryan Prakash in the meeting and it's not me. I didn't join to another account.
You did not?
I did. That wasn't me.
Wow. I see. There are a ton of Aryans are joining. I am more of the merrier, but if they can.
So like if anybody else with joins, then we can remove them because I only have one account.
Okay,
Let that person join again for that person. But
okay, I'll move that person. Okay, fine.
thanks.
Okay.
okay, sir. So first I wrote down all the information which was provided with us, which was Ram guessed a three-digit number. Then the digit zero was not used. Then Rahim wrote down same number but in the reverse order. And then John subtracted the two numbers. Now then I found out that no matter what example we take, such as suppose 943 minus 439 or 723 minus 327, the
Uh-huh.
difference will always have a 9 in the tens place.
Okay.
So I knew that the answer will be 9.
Okay. So you did a little bit of trial and error there.
Yes, sir, like because the middle digit will remain the same. When we are subtracting the unit digit of both the numbers, we will always need a carryover.
Uh-huh.
That is why.
I see. I see. So you also have a little reasoning there. That's good.
Yes, sir.
Okay. Okay. Very nice, Kanak. It's great that you tried the problems.
Thank you.
So I also want to tell you guys about how we find these problems for post Olympiad and what exactly is our philosophy. Basically, see, the thing is that it's too easy to actually um, steal problems because everyone is taking problem from some place or the other, right? I mean, even if you check the problems in Indian Olympiads, they are taken from maybe Russian Olympiads and stuff like that. But that is there. I mean, we always take problems from other places, of course. But we also have a mechanism of making problems inside Chinta. So we have a little team of people who love mathematics, and our students contribute as well. And all of us take the problems together, pull in the created problems, and then some of the best problems make out to the actual Olympiad. In fact, if you guys can contribute problems in Chinta, that would be also great. If you think of some problems that you can think, that you can create yourself. Okay. So anyway, thank you everyone for joining. I think the awards will be distributed. I mean, this was like the ceremony. Now you will be sent to you and in some form or other. And keep on doing great mathematics, and I will see you when I see you next. Okay. Thank you everyone for joining. Congratulations to all of you. Take care. Bye.
Bye, sir.
Yes.
Thank you, sir. Bye.